welcome. Andrei is a new friend of DeSci Labs, who I got the chance to meet during our time at International Data Week about, 2-3 weeks ago. It's, as you can tell from some of the links that he shared, he is also an IPFS enthusiast who would love to see the idea of content addressable storage applied to persistent identifiers. So I'll let Andrei introduce himself for a second. But Andrei, I think everyone on this call already understands the value of content addressable storage. So this is probably one where we can get into some of the grittier details of the specs that you've designed and just kind of discuss and see what people have to say. So with that being said, do you want to just give a quick introduction of your background?
Yeah, for sure. So again, my name is Andrei. I'm a data stewardship programmer and the software developer of Elettra Synchrotron at Trieste, which is a lab in Italy that produces and uses synchrotron light. So the laboratory is producing a lot of data, and we always have problems with sharing the data, the analysis pipelines, and the intermediate data, and identifying all of the data we produce. So now we have also an experimental IPFS node on our server room, and we are trying to find the easy and more or less convenient way for such a big facility to identify and to prove the origins of data. So this is what I am working. It's my side project after the European Open Science Cloud data sharing project ended in the last year. And this is what I am working at Elettra. Oh, well, for now, that's all of my introduction. I'm also a former robotic scientist of Bauman University in Moscow. So also I'm now, it's totally a side and pet project. I am exploring the possibilities to share the data across the robotic, let's say, robonomics, the content addressing and blockchain driven networks of robots. But it's now not in the not in the stage on which we can discuss together. Okay, so I think we could start.
Yeah, we should be able to. I'm gonna poke one question. I'm gonna throw in a chat asking for consent to record just to make sure that that's okay. And in addition, we're hoping to maybe post these on the DeSci Labs YouTube so that we can share this around in case people think that's interesting. Are you okay with that?
Yes, sure.
Sweet, thank you.
Okay, so I will share now my screen.
Is it frozen?
Is he frozen? Okay.
He might be frozen. Yeah, I think that's okay. I mean, just rejoin. There we go. You're on mute again, Andrei.
I thought I froze.
Yes, I've lost my connection, so I will try to share the screen again. Maybe that's something wrong with Zoom.
Do you have permission to?
Yes, I have.
Okay, good.
But the graphics doesn't work, so probably. Can you hear me still?
If it's easier to share the file or links, we can share on your behalf.
I will now send a link to DPID.
Okay, I have the nodes, so I can share that.
Okay.
And this is the Google Doc that you made around decentralized persistent identifiers. Oh, here we go. Okay. Yep, we can see it. Good to go.
All right, feel free to kick it off, and I'll try and move as you go. Let me know when you want to
Okay.
switch.
Thank you. That's great. So it's just a little talk about the persistent identification, and at first about the design problems and the specification proposal we made after the outcome of Expanse project. Can you move to the next, please? Yeah, so it's at first, it's about the problems we encounter at identifying our data on Elettra Synchrotrone. And the first is that was for the ordinal infrastructures like DOIs, the identification and that metadata binding to the all digital entities addressed by this persistent identifier are implemented over the existence agnostic link. For example, DOI doesn't know which data and metadata it should address. It's just a link on which without underlying database record, it doesn't work. So it doesn't allow us to implement the linking of over the metadata and digital entities stored under the existing DOI, except the cases when the DOI metadata should change. And also for the current state of the persistent identification, the identification provider is the only source of provenance. So, for example, for the DOI or handle, we cannot recreate it from the existing data or the digital object or the metadata. So we should just trust on the root authority of the identification provider. Then it's obvious leading that the resolution is declared as a unidirectional process. So again, the reverse lookup is not possible. Can you move to the next, please? And here is just a schematic of how the centralized PID infrastructures are generally developed and implemented right now. This scheme is borrowed from our outcome in Expanse. You can see it on the Zenodo link I shared to the chat. And it is actually probably the same for handle and DOI infrastructures. Next, please. After exploration of this scheme here at Elettra, me with some colleagues tried to develop the schema for the decentralized model. It is a first version of this schema. I also presented it on the IPFS presentation at Elettra. I also shared the link. And this is let's say the decentralized architecture that utilize hash functions, the selected set of the hash functions. RI is a research institution or research infrastructure which provides, which acts as both PID provider and PID verification point. So this scheme is based on the customer signatures, which is a cryptographic signature, hash functions, and data URI stored in IPFS and provided from the PID affixes. Some of these the ideas encrypted in this scheme also will be presented in the specification. I will try to explain also by the Google document. Next, please. Here are the expected key features we tried to implement during the development of our specification proposal to avoid the problems we encountered from the centralized model of persistent identification. Let's say some key points here I would like to highlight. At first is a fair compliance, because Expanse project was dedicated to the fair data models and the data sharing under fair conditions. And this forced us to include this feature, and also to try to include in our working model underlying access control. For example, yielding the access from on the last mile from metadata to the actual digital entity to external access control solution, at least to keep in mind this possibility. And also, the second highlight I want to do is the safety feature. Because the abusive usage of, for example, DOI, now it seems possible, because we can easily, after the short that data site shut down, if I remember correctly, this March, we could easily imagine that let's say, the attacker could just capture a control over one of the resolving nodes of DOIs, and then use it in an abusive way. So we decided to try to think about the mechanisms providing the safety. And the third point is transparency and reproducibility, the underlying reproducibility. So the key point here is all of the network participants should be able to share the same software. In the ideal model, this software should always be supplied over the same persistent identification network. So here are the main highlights I wanted to do. Please move it to the next slide. And here is a first model we developed for our PID concept, which for sure it could be changed and under the conditions we would agree to establish. And here are just the list. So we supposed to propose all the data over a network of the peers connected over IPFS network, and this IPFS network probably should be the only transportation protocol the infrastructure should use. And
really
every sorry,
interrupt, Andrei. Ellie, can you scroll down further, please? Thank you.
Yes.
Sorry, keep going. Thank you.
Okay, thank you. The next key feature is that every peer in the infrastructure should be able to work as untrusted resolver node, and also to provide the public gateway, public resolution gateway, once he would decide, for every valid PID we would resolve over our infrastructure. The second highlight here is that in our concept, it was also the concept of subsets. So imagining our PIDs, we were thinking about some supersets which would be managed over some web of trust, consisting of some trusted peers, and every operation over this trusted peers should be ratified via all agree mechanism, as it is described just down below. And also there would be the subsets, and every subsets would be managed by the dedicated peer, and this peer takes a responsibility to share the lookup table for every PID minted inside this subset, but giving the peer the right to hold a subset and to make himself responsible over the subset should be ratified by all of the trusted peers of the network. So this was an initial model. Then the trusted peers yield the management of the subset to the so-called publisher peers. And the verification is done over the identic IPFS content IDs of all of the lookup tables shared over the infrastructure by all peers. This is a, let's say, native mechanism. We were thinking about developing this specification proposal. We could see also the full document, not already full, but the document we developed at Elettra on the Google Doc via the link shared in the email. Please move to the next slide. And so we here have three types of peers defined in our infrastructure. The trusted peers actually formulating the web of trust, and they have all of the possible rights which are existing in our infrastructure. The next type is a publisher peer who takes a responsibility to hold the subset inside the given superset of PIDs. And the key point here, I want to highlight it now. It's also described below, but I want to highlight it now for the publisher peers, that it also would be the subsets, for example, for reversely compatible DOIs and the PIDs of the different types. For example, we could imagine the DOI society registering a trusted peer or even the publisher peer in our infrastructure and dedicate to us some set of already minted DOIs. And we can create a cross-resolution lookup table. So this is why developing this specification proposal, we decided to also include a publisher peer. And the other key feature is that every trusted peer has a right to declare some PID minted in the subset as verified or suspicious. So there is a, let's say, the native mechanism to declare that some PID is used in perfectly properly or in improper way. But it is the question for being discussed in future. And the ordinal peer is an untrusted peer that has no right to publish or mint PIDs, but it has a right to resolve, reproduce existing PIDs and retrieve the data, providing also this data and metadata over the public resolution gateway. So here are the types of peers we're thinking about. Please move to the next slide. The second problem is an integrity maintenance inside this infrastructure we were thinking about. The first point I've already described, it's identical resolution table IDs. Actually, it's a content IDs inside IPFS network. And the mechanism here is maintained via dedicating several standardized set of the IPFS entry points for every peer in the network. We will see the description of this below, and this is a highlight here. Also, the trusted peer can declare the given PID as suspicious, but there is also we were also thinking about the weighted mechanism, so it will be an open vote for some already minted PIDs. But this we have doubts about, let's say, how this mechanism would work, because the weighted mechanisms are vulnerable to for being used as let's say let's say, election attack. All this is the next point is already described. It's about sharing the same software over the whole infrastructure between all participants. And the other key feature, also connected with the IPFS feature of minting IPNS, interplanetary name system, entry point keys, which are already signed by the node owner. So every ratification operation should be signed by the cryptographic key owned by the trusted peers. So this is a task probably should be solved, which probably should be solved implementing the infrastructure over our specification we propose. Okay, please move to the next slide. And here are the IPFS entry point we declared for every peer in our infrastructure. And this set of entry points, every point should be, in our suggestion, should be implemented over the dedicated IPNS key. Because the publisher subscriber model is still work in progress in IPFS, so we decided to implement this over the IPNS public keys. The trusted peers list should be published identically by every trusted peer in the network. Pending operations list also should be published by every trusted peer. And also every trusted peer publishes the list of supersets available inside the whole infrastructure. On the other side, the publisher peer publishes the subset. So that's a lookup list of PIDs issued under the subset on which this given publisher peer is responsible on. And now also there are the lists of verified and suspicious PIDs available for the whole network. And every publisher peer and every trusted peer should publish them and should verify their integrity. The broadcast is just a mutable message that the peer can publish, for example, for announcing something or make really a broadcast like it is done in the systems like in the telegraph system, like for example Swift. And the last is a peer info. Please move to the next. Here are the highlights. We were thinking about developing the mechanism to maintain network status consensus. So here are some social contracts on which all of the participants should be obliged to do. And so the first is already described, the identity of the IDs, content IDs. Here for the trusted peers list, superset list, and subset publishers list, which are published on the entry point of every trusted peer. And also the obligations for the peers. For example, for publisher peer, there is an obligation to not only to verify the integrity of trusted peer list, but also to verify the integrity of the subset publishers list. So it's something like the collective responsibility here. And every publisher peer signs its own subset PIDs list by his own private key. It's also an obligation. The untrusted peer for being able to resolve the PIDs, he should verify the integrity of everything before actually running over all the trusted peers and checking the CIDs they are publishing on their entry points for being able to start the resolution of the PIDs. Please move to the next slide. And well, for now, it's all highlights I wanted to do today. And here are the discussion points for the future, because after the discussion with Eric and after studying the documentation of the DPID project, I also together with my colleagues realized too that some features are already developed and successfully implemented. So here are the future discussion points. So the close integration with your project seemed to be really feasible and really useful for every one of us, because the features we have already have them. The next point, it was proposed by Eric. Thanks a lot, Eric, for bringing this up, that we should minimize the social contracts inside the spec. But thinking about this, I think it is a topic for the next for the discussion. Okay, can you please scroll a bit down? No. Just like this, please. I think, yeah.
Off earlier.
Yeah. I think we also should keep in mind that we would provide some subset in our PID infrastructure for the societies controlled by the Web of Trust principle. For example, like it is done now for the peer-reviewed materials in the DOI society, or the, for example, Software Heritage Society, which is also brings up the question about the compatibility with not only with reverse lookup, but also with the version control systems like Git. The next is to systematize the operations that should be available for every participant of the network, which is already mostly done in your project. So the integration will be again a very good idea. And what I didn't see now as a possibility in your project, and what we would really would strive to do, is the cross resolution and dedication of some subset of our PID, let's say PID space for the cross resolution at first for the DOIs, because the DOI is most popular persistent identifier right now. Well, so for now, that they are all highlights. We can just leave this slide on. Thank you very much for listening, and let's now start the discussion. And we can discuss the exact specification proposal we have on the Google Documents. If you want, you can share the screen with Google Doc.
Yeah, for sure.
Sure. And
Okay.
I guess maybe to kick off the discussion, I'll actually call on Sina maybe to unmute himself and potentially give some thoughts.
Yeah, great. Thank you. Thank you, Andrei, for the presentation. And yeah, definitely we have a lot of similar lines of thinking on how we're implementing these sorts of systems. I do want to maybe ask a couple questions around.
Yes.
Yeah, so I want to ask a couple questions around. So number one, I wanted to ask about how are the trusted peers chosen? How would you think through that?
Well, from my point of view, it's only my opinion right now, because I discussed it with the colleagues, but we didn't agree on anything. In my opinion, it should be like the following. The first, let's say, the trusted peer running at first the system, for example, it would be Electra or the other large-scale research facility. It runs the software, runs the public resolution gateway, as it is done, for example, in your project, and it starts to communicate with the other facilities, and for example, universities, to enter the network and to ratify the operation for including the next trusted peers in the web of trust. So the first ratification would be done only by 1 or 2 participants, and afterwards it should be all agreed. So this is a mechanism we mentioned.
Okay. And then the other question I had was related more into like the implementation around the actual PID itself. And you know, you mentioned something about IPNS as being a potential way to implement it. Is that correct?
Yes, exactly.
Okay. So my understanding of IPNS, and correct me here if I'm wrong, but I believe the implementation of IPNS as it stands today is effectively a pointer that you can update to a CID effectively. So it's like a name that can be pointed to a CID, and you can mutate that name at any point, right?
Exactly this. Yeah, but also the very important point here is that the private key should not be shared. So yes, so every IPNS entry point should be owned by only single peer.
Okay.
And this is a point.
Yeah. Okay. And then so my question kind of around this particular point, this particular implementation with IPNS is the, you know, the ability to audit the change. So let's say I publish a change. So I have an IPNS name and it points to CID1. And then all of a sudden I make it point to CID2, and then I make it point to CID3 and so on. How do I capture these changes in a verifiable way, in a tamper-proof way, so that I can guarantee against you know, content drift?
Yeah, this is for now. It seemed from maybe Eric or anyone else could correct me if I'm wrong. But studying the IPFS documentation, I saw that probably it's still not solved the issue inside the IPFS network. So it is the question for the discussion about should we use exactly the IPNS or not.
Okay, got it. Okay. And then I'd say one thing that, you know, maybe I can talk a bit about how we've been approaching PIDs and kind of you know, our current approach on the protocol. And so I think in our you know, kind of vision and the what we've currently been working on, it's almost like every single user is an untrusted user, basically. And basically every single user has the ability to, with their own private key, sign a you know, some message, and as soon as they sign the message and they publish that to the network, that becomes the identifier of that first message becomes a PID that all subsequent updates can be linked to that, so that every single new update is linked to that original submitted PID. And that actually solves the problem of provenance tracing. And then the issue then is so, and also that's a cryptographic function that produces that initial identifier. And what that does is it makes it so that anybody without any permission can begin publishing PIDs. And then the question is, okay, which ones are, you know, junk or noise or follow a schema that is relevant to science, right, or to research? And for that, we're using a way of indexing based on the actual content of the message, so that when you publish a message, if it follows a certain schema, you choose a schema that it follows. And then every single message that follows a certain schema, you can actually query for all messages that are published with that schema. And once a message has been initially published with a schema, the schema is pretty much constant throughout the life cycle of the object of the PID. And this has an interesting property of for the findability part of FAIR, where you can actually you have no opinion on whether people are publishing junk, because you can simply filter by schema, right? And so certain applications can, oh, I see you're pulling something up here. Okay, okay. Okay, so yeah, so exactly.
I think this is Ellie's screen.
Okay, yeah,
so
perfect.
she might be
Yeah.
sharing her personal notes.
Oh, okay. So yeah, basically,
Ellie, would you mind going back to the actual presentation with the questions that are up? Sorry.
yeah, so basically the way of doing it with in this manner where it's actually completely open and permissionless to begin publishing data, and then you have these schemas where then any user, any external user, not who's consuming the data, can then query by schema. Then all of a sudden they can find the most relevant content that they're interested in, right? And that helps you eliminate noise and junk and so on, right? And then
I think.
Sorry.
Go for it. Sorry, I thought you were done. My bad.
Okay, so but basically, another concern in a decentralized system is going to be network partitions. So what happens if certain nodes go offline, or you have to pick up some sort of way to shard the data, because not every node has unlimited storage capacity. So there's going to be probably some sharding of data, and in that model, it may be actually appropriate for certain agents who are interested in preserving certain content to be constantly running queries for these schemas, and then actually registering them. And in our case, we're registering them on a blockchain, using a smart contract. And the reason why is because you can maybe publish objects with a certain schema, but later if they go offline, then there's no record of that object necessarily, if the data becomes unavailable. However, if you have certain agents continually querying and indexing the objects that they're interested in, at least for the metadata, maybe not all the source data if the peers go offline, but at least to contain the metadata. If you do that in a permissionless way, where anybody can add records, for all the objects that match a certain schema, then you're actually able to tolerate network partitions. And also, I believe that's one of the FAIR principles. It's like, even if the data goes offline, at least have a record of the metadata, right? And so that's like one of the things that we've been thinking about. And then I'd say another thing is just to talk about, there's two things on the Web of Trust in terms of validating PIDs, and then also with the DOI compatibility. So two separate things. So kind of my view on the Web of Trust is it's going to be really tough to regulate content creation, in terms of, like, you can have several agents producing content, and it's very cheap to produce content. Regulating that content in terms of, like, making sure it's valid and so on, it's probably quite tough, like a lot of effort required to do that. So I'd say, like, allow anybody to publish whatever content, and then we can index certain schemas, and then for the most relevant schemas, if you want to then do some validation to determine if that schema is actually, even if it fulfills a schema, could still be junk, well, then I think you could actually have that social element where, you know, perhaps experts in certain fields, perhaps with public profiles, review the content and actually issue an attestation to that content saying, hey, I validated it. And I think you were kind of alluding to something like this in the kind of web of trust part of things. And yeah, we definitely think that that is a component. And then I'd say also on the DOI side, I agree. You know, having some sort of bridge so that you can resolve DOIs and perhaps even upgrade DOIs so that you can take perhaps some research, because we all know the issues with DOIs. They, you know, they can suffer from link rot, so they can 404. They don't really support versioning. There's been like sort of band-aid solutions, you know, if you look at Crossref or Crossmark that attempt to track version updates over time, but those aren't cryptographically guaranteed solutions. So we can actually do cryptographically guaranteed solutions for, you know, basically taking a DOI, allowing somebody to claim it, you know, via some, you know, whether we can, there's a couple ways that we can actually do the claiming. I think that could be interesting. You know, so there's plenty more to be discussed on that part of it, you know, to prevent spoofing and that sort of thing. But I do think that there isn't, you know, there could be a mechanism to claim a DOI and then actually register it, and then allow a group or one or more people to actually push updates to it, and then have that record be able to receive an attestation from like on the social layer of actual like researchers who are familiar with the work, to actually put a public profile and issue an attestation saying, hey, yes, indeed, this DOI is the real one. And boom, we've upgraded it to a decentralized one that has cryptographically verified version tracking. And oh, boom, we added a bunch of data to it. And here's how it's all linked together. Oh, and it can actually accumulate social markers, kind of boosting its reputation. So I think a lot of these points kind of like align in the spirit of what we're trying to accomplish. And I think it comes down to like, you know, diving into the nitty gritty technical details and kind of going through all the work of, you know, walking through all these points. But in general, that's kind of an overview of what I've been thinking about, and happy to dive into more or have, you know, give more details on any component.
Okay, thank you. And what I wanted to say at first about the let's say the web of trust to verify some subsets of PIDs, because what we already encountered in the scientific society is the let's say predatory. So, for example, the predatory journals publishing and minting DOIs for junk articles. And this is an aspect in which what you have proposed, the schema-based aggregation, it perfectly works for eliminating the, let's say, noise content, but it doesn't work against this. This was the thing we were keeping in mind, trying to develop the web of trust and the ratification mechanism. So, but well, it's the question we should discuss deeper, because there are a lot of aspects underlying.
Yeah, I agree. And I think a big part of it, to be honest, is the linking of a public profile along with that marker of quality or verification.
Yes, I agree. But also it should, I think it could be in the, not for the whole infrastructure, but only for the subset. It would be also the possibility, for example, to link, and as it is now already possible in the DPID, to link the reviews for the project. With reviews should be let's say cryptographically signed, but this signature should not be visible to anyone, anyone except the author. or the admin of the given PID. This is
Why,
one of the ways I see.
why would you avoid sharing the signature publicly?
Because you know the mechanism of peer review.
Oh, I see.
Except the situation of when the reviewer wants to share his name and personal information, the entity, the digital digital or material entity of reviewer should not be discovered.
I see. That I could see that. So you're saying, like, let me see if I'm understanding it correctly, that there's value in issuing some sort of, quality signal from an expert, but then without revealing your identity. Is that the idea?
Yes.
Okay. But then wouldn't it also be valuable to reveal your identity, or what are you mentioned some negative aspects of revealing the identity. I just want to understand exactly what those are. It sounds like maybe you could be competitive.
Yes, it could be. It could be competitive. It could be competitive. It could be in the, let's say, in the state of racing between two, for example, two reviewers, or it could be also the reviewing attack on some PID. So, and it's again the social aspect, and this is why again we were trying to think about the web of trust in this aspect.
Yeah, I think that's a good idea. I think giving the option, I think, to allow for some sort of, issuance of a signal of quality or some signal that, somebody has reviewed it. That's definitely with the option to reveal your identity, right? So
Yes.
you could maybe perhaps not reveal it, or you could reveal it depending on the situation. And
Yes.
I think that option is yeah, I could see that being very useful. I could also see being very useful, potentially being able to, along with that signal of quality, be able to potentially use something like a proof, or some ability to attach some data that shows, hey, maybe maybe I can show that I belong to an organization. So you have different, more granular levels of information sharing. So maybe it's like, I don't share my name, but I share an organization that I belong to, and I can potentially, there's ways to actually verify that, from with a third party. I could also see potentially, if we look at the current scientometric machine, where we have all these different, scores and mechanisms of kind of like ranking research productivity, and there could be potentially the ability to sign it with like an H-index bucket, for example.
Well, it's it's a good example. It's good example. I don't know now. I cannot even think about how feasible it would be. But what I would tell that we have already a problem of identification for the facility itself. And for example, sharing the metadata about some organization, it should be a way to link also the IDs of the researchers. And this should be a possibility. I think in the PID infrastructure there should be a possibility, as you saw, as you said right now, to reveal the exactly the researcher acting from the side of the facility.
And you could also do something potentially very interesting, where you have self-selected groups of organizations that all say, hey, we trust each other. So it's like perhaps several different universities that say, hey, we're like, it's almost like in sports, they have different leagues, where it's like, hey, we're all in the same league, right? We all self-selected and we all agree that we're all in the same league, right? And so we all issue to each other, hey, we're all in the same bucket. And perhaps there's a way to say, hey, instead of revealing that I belong to university X or organization Y, I can say I belong to this group of highly trusted organizations, and therefore I can issue you a quality signal that comes from that group, but you don't know exactly which organization or which individual it was. And it could be up to the issuer to provide that level of granularity as a choice.
Yes, exactly. And this is a very important point. Thank you for bringing it up, because in our specification proposal, we thought about only one web of trust. So you are bringing up the idea of using the several web of trusts, not for given subsets of PIDs, but just in the infrastructure itself. And it seems for me really a very good idea.
Yeah,
Just
I think
as
it's exactly. Go for it.
I just wanted a quick clarification question in terms of the web of trust thing. So what you were saying, Andrei, is that specifically we were thinking of a web of trust. Like what this conversation does is it builds from a web of trust just into what you were thinking, which is right before publishing. It's like who gets to publish, and now we also have a web of trust after publishing, which determines what is relevant.
Yes, and this was an idea just brought up right now. So in our first specification proposal, there were no this idea. So thanks again. It's for me, it seems really a good point.
Yep, and I think it creates more credibility if you have the creation of these groups and also the publishing be effectively permissionless with
Yes.
With like varying levels of quality signaling that you can choose to provide, right? And that's how you stand out, and making it very easy to query so that a consumer of the information can choose, hey, I want to ignore all this garbage because I know it comes from like a Chinese paper mill, right? And
Yes.
or it just doesn't follow a schema, or I know that this, nobody's vetting these guys, right? So I'm just going to ignore it.
Yes, well, exactly. I understood what you said. Yes, it's about this, and also, in my opinion, about the organization, this kind of league or something like this, acting as a reviewer. So the level of trust for these network organizations, which should be quite higher, even, for example, for the single university.
I agree. And then what's also interesting about this dynamic is if any individual within that group misbehaves, then the group should have the option of removing the organization that individual belongs to. And that could be a really interesting social mechanism to align good behavior potentially.
Yes, but here I guess it would be also a good idea of the ratification mechanism. Not, I don't think
exactly.
it would be useful to use a all agree model, but we could think about the other models.
Absolutely. And I think what's really super interesting about this too is if you make it very flexible, because every organization and group of organizations has their own culture. If you make it very flexible, then you can leave it up to these groups to kind of give them the tools on how to organize and how to manage their own organization and individuals. And then what would be really cool is like you fast forward 10 years, 20 years, and then you see which ones are the best models that actually survive over time, which I think is like probably the most realistic way to actually see what works, the quickest way to actually see what works, and the most it's like a free market mechanism effectively for social proof. Yeah.
Or the common evolution mechanism, probably because I am now establishing some small group of scientists working on the persistent identification. Probably it would be also a really good opportunity to discuss with the scientists working on inside the infrastructure of DOIs and handle, because we have them in our small mailing list. Maybe it would be really a good, let's say, sightseeing for us about how the models of trust and the models of minting and quality signals evolve.
Yeah, makes total sense. And I think it's really interesting too, because you see I've often like put myself in the shoes of those folks who, I don't know how many years ago, 20, 30 years ago, had designed the handle system, for example, where they're organization scoped identifiers. And I've actually talked to I don't know if you know Arc Institute, John Coons over there, and he's actually been super invaluable in teaching me a bit of the history and walking me through all the kind of design decisions. And then I present some things that we're thinking about with technology available today, and it's just like I wonder what they would, given the landscape of options that we have and the ability to cryptographically sign things in an easy way and actually like compose a lot of these cryptographic primitives together. I wonder what they would come up with given that new information.
Yeah, it's really an interesting topic, and well, maybe we would find an opportunity to talk with these persons who are already involved in these infrastructures, and to have some knowledge for them about how would we adopt and implement, for example, the reverse lookup compatibility, because every centralized structure would degrade.
Yes. Although with the reverse lookup, are you talking about like being able to have an index that goes from CID to PID?
Not only this, but also, as I described in the presentation, for being able to dedicate the subset of the whole PID space, for example, for cross resolution of DOIs and backing up the DOIs, some DOIs as the let's say side effect backup solution.
Yeah, I see what you're saying. So that actually could make sense because
yes, I believe.
Yeah, because it's basically a way to onboard legacy organizations into this model.
Yes, exactly. And this is what, for example, here at Elettra, we should always keep in mind, because we have a lot of legacy systems, and even the identification systems. For example, we have a need to identify the tape data storage libraries and the elements of these libraries, for example, to communicate with the system in a manual way, not in the automatized way.
Yep,
because the system, these systems, let's say they are they should be somehow replaced in some years, and no one knows how to handle a lot of storage entities. Without,
that's really interesting, and I could actually see a way to do this in a self-serve capacity potentially. So my understanding, for example, of the DOI system is that you can register for an organization namespace, and what I could see is actually the development of a toolkit that allows you to import, like backfill all your existing PIDs into a cryptographically verifiable storage system, and then be able to then make that available for future use. So it could be actually seamless, and I could even see the verification of that being very similar to how you verify a domain name using DNS records. You could publish like a specific identifier using your organizational namespace, and then that could be the verification required for the system to signal that it's actually legit. It could be interesting.
Exactly. Yes, exactly. I see the same. This actually the same model of reverse lookup and cross resolution, because well, the society really needs this. That's
No, I
already.
totally agree. This is really cool.
Yeah. And
So yeah, the DOI compatibility problem has been something that's we've kept bringing up, but it's one of those things that we're like, we have a couple different ideas, but we're still a little bit we haven't gotten down to it and experiment with actually implementing it. And one of my concerns is, how do you actually properly be able to claim it without people spoofing it, right? And I have some thoughts in mind, but so one of them is like, look up the actual record, resolve the PDF content, or look it up on Crossref, right? And then extract the ORCIDs from there, and then give it an ORCID authenticated user that belongs to that work, allow them to claim it, right? And so I think it's kind of a cool idea, but my concern with that is there's a lot of pitfalls with like on a per journal, like a per publisher basis and a per organizational basis, and also per field basis. Like the culture of actually attaching ORCID identifiers to your paper may not be present in certain fields or certain organizations. It could be maybe email addresses. That could also be a potential one. But then you also have to think about, okay, I'm dealing with potentially looking at PDFs and then having to parse them, and also keeping in mind that these PDFs could be updated at any point. So there's a bunch of complexity there. But if the organizations themselves were involved somehow, that could be potentially a more reliable way of doing it.
Sure, I totally agree about the organizations, but about the existing persistent identifiers, what I would say, probably in my opinion, we could look at first for the API exposed by the providers of these PIDs, and look around calculating for example, the IPFS content ID over the existing reply from the API. So to determine the constant part of the reply. For most of the, it's probably a more technical way, but for most existing persistent identifiers like handle and DOI, this should be enough to track the changes in the API reply, and potentially to prevent some cases of spoofing.
Yeah.
Maybe, yeah, also because we have a content ID available for all IPFS network, it could be perfectly easy to verify.
Yeah, that makes sense.
Yeah, I think that's the first thing we can keep in mind thinking about this possibility. And just a little remark, because well, I'm Russian, and I know that now Russia is applying a lot of resources for spoofing and for let's say unexpected changes in the URI resolving model. I could say that probably the only kind of the system that could withstand with this coordinated efforts on spoofing is a decentralized system. So I think even building the webs of trust, we should not allow the system for being torn apart between the webs of trust. So the system should be always interconnected between all nodes.
Yes,
Otherwise,
something
yeah.
about like republishing the lists amongst all nodes.
Yes.
Yeah.
Yes, and this is why it was my idea initially. I wrote in our specification proposal about the identicity of all CIDs for trusted peers list, publisher peer list, pending operations, and so on. This is why I decided to include this. I think the verification should be one of the few social obligations for every participant in this decentralized infrastructure. Because otherwise, all of the participants would be vulnerable to the spoofing.
Yes, I think it's interesting if you allow like a gradient of signals of, you know, for me to consent to giving you like a, you know, incremental signals of who I actually am, you know. And I think we discussed a little bit about this earlier. It's like being able to reveal portions of your identity, and also being able to vouch for others. You know, those could all be very useful tools.
Well, yeah, here I could say that I completely agree. Okay. And I saw that. Okay. It's already past 1 hour and 10 minutes.
Yeah, I actually am gonna have to leave in just a second. Andrei, I think we as a team would love the opportunity to continue this conversation with you past this seminar. I'll reach out to you afterwards. It may take a few days because I'm fully engrossed in where I am at the moment. But if at all possible, let's continue this because I think that there's a lot more to discuss. And hopefully this is something where we can coordinate efforts around some of the stakeholders in that email list, because you're right. If we can do this hand in hand with DOI, it's going to make things a lot faster and a lot more effective than if we just do it on our own.
Yes.
So yeah, totally on board. Sina, do you have any closing thoughts for all of this?
Oh, I just really appreciate, you know, it's quite a treat to see all this work done in your slides and your documentation, Andrei. I really appreciate your presentation, and it's great to see people who are deeply thinking about these problems as well, and super exciting to, you know, to start this conversation. So thank you.
Thank you very much. One question I want to address. May you share with me the recording of this seminar to share in our mailing list with the other participants from the scientific institutions?
Mm-hmm.
Yeah, of course.
Okay. Thank you very much.
Okay.
Perfect.
Well, with that being said, thank you for taking the time today. This has been a pleasure, and it is actually really fun to hear about other people who've been thinking about the same topics. So with that being said, we'll follow up with the recording, and I'll follow up via email probably sometime early next week.
Yes.
And
Hope so.
we'll talk to you soon.
Yes. Thank you very
Thanks.
much.
All righty.
Thank you.
Thanks
So much.
Thanks for
Bye.
your attention, and have
Of
a good
course.
day. Thank you.